maximize. All right, good. Excuse me. So the last thing I think we went over is adding or subtracting rational expressions with common denominators already. In other words, the denominators are the same. Is that correct? All right, good. Now, some of them, like part A right here, were really simple. It was straight up, look at the denominators. If they're the same, rewrite the numerator as one whole numerator, and then do your math. Now, before I go any further, what was that one thing that you had to be careful of? And it has to deal with the definition or the rule that the book actually gives us. And I was like, oh, somebody is coming in hot. Who is that? I think it's Zach. Yeah, it was Zach. Zach he's fighting his computer right now. I hope he wins. All right, anyways. So what was the one thing that we need to be careful of when we are, and I'm going to be more specific, what do we need to be careful of when we subtract rational expressions?
We need to put them in a parentheses.
And why do we need to put them in parentheses?
Because of the sign.
Yes, perfect. So if you look at letter C right here, okay, notice that we have 3x squared plus 2x in the numerator and then x minus 1 in the denominator. And then the second fraction is 10x minus 5 in the numerator and then x minus 1 in the denominator. The thing you have to remember here is this. When you set up this problem, okay, you are going to be subtracting this entire numerator. So a really good and effective way to never ever forget that you have to distribute the negative sign, which is highlighted in yellow, is to put the second numerator in parentheses. Okay? That is the most important part. Are there any questions so far? All right. Now, if we continue with this problem, we distributed the negative sign. So let me go ahead and highlight that. So distribute this. That is how I got negative 10x plus 5, where I just put that star. And then we group like terms. And the last thing that we always want to ask ourselves, can I factor anymore? Another way to ask this question is, can I simplify? All right, remember, fractions need to be put in lowest terms. So I always need to check, no matter what my result is in the numerator, I need to try to factor that to see if anything reduces. And in this case, it actually did. All right? So are there any questions with this problem? Because that was the last one that we did. All right. So why don't we just do another problem together? How about that? All right? So here's an example. All right, and we're going to do 4x squared plus 15x over x plus 3 minus 8x plus 15 over x plus 3. Okay? How are we looking so far, everyone? Pretty good? All right, now, I'm subtracting two rational expressions. Therefore, I need common denominators. These denominators are definitely common. They're both x plus 3. So I'm going to rewrite my problem with x plus 3 in the denominator. And I'm going to write out the entire numerator by putting each numerator in parentheses. And if you notice, that only took me 1 second extra to do that. So don't be lazy and do it. Okay? From here, we're going to distribute the negative, okay? And we're going to just write out the numerator again. So x plus 3 is in my denominator. In the numerator, I get 4x squared plus 15x minus 8x minus 15. Okay? Now I'm going to group any like terms I see in the numerator. So I have 4x squared And then I have 15x minus 8x, and I think that's going to be positive 7x minus 15. All right? Now everything's all good, but I need to ask myself, can I simplify this numerator any further? Can I factor? All right? And the only way to check is to do it. That's it. Sometimes you will factor the numerator and nothing cancels out, and that's fine. That's the best case scenario, because then you know, okay, I was completely simplified. I didn't have to worry about anything. So you always want to try to simplify, or better yet, factor the numerator. So I'm going to just draw a big line here because that's what I'm going to do down below. All right, no GCF, trinomial, a is equal to 4, AC method. So I'll get my idea, a plus and a minus. Okay, now I'm going to take a times c. That's going to be 60. And 60 is okay, it has a lot of factors. So 1 in 60, 2 in 30. Is it 3 in 15? No. 3 in 20. 4 in 15. 5 in 12. 6 in 10. And I think that's basically it. So from here, I need to find the pair of factors that combine to give me positive 7. One is negative, one is positive. That's going to be right here. Minus 5 plus 12 equals positive 7. So I'm going to rewrite 4x squared minus 5x plus 12x minus 15. And then I'm going to factor by grouping. So I group the first two terms. I group the second two terms. In the first grouping, I can factor out an x. In the second grouping, I can factor out a 3. I'm very happy because my binomials inside the parentheses match. And the final result is going to be 4x minus 5 times the quantity x plus 3. So I'm just going to transfer that up into my problem at the very top of the screen. And from here, I can see that the x plus 3's reduce. So I just scratch them out. And what's ever left over is going to be my final answer. Good? I would love to hear some feedback on this. How do you feel regarding factoring and the flowchart? Like, does that stuff help? Okay? Like, does that help? Like a good unmute, yes, it helps. Because here's the thing. Many of you need to go on to 108. And factoring is a huge part in 108. So if you have a really good understanding of factoring, okay, 108 is going to be easy for you. But if you don't understand factoring that well, it's going to be tough. All right? So please make sure you ask questions. Make sure that you use the flowchart. The more you use it, the faster you're going to start memorizing it. Okay? Because here's the thing. I'm cooler than the other side of the pillow. And we all know how cool that is. Right, B?
Can you say that again?
I said I am cooler than the other side of the pillow. Do you ever go to bed at night and you put your head down, the pillow's real hot, and then you flip it over and it's nice and cool? That's me, but I'm even cooler than that. And what I mean by that is this. I allow you to use that factoring flowchart. The next professor may not. So, take advantage of it now. Use it every single time. Run your finger along all the little pathways. Talk out loud. You will start to memorize it. And the faster you can understand that and memorize it, the easier everything is going to be. Because, if you don't get the right professor next semester, you're going to sit there and go, I know how to do this if I had that flowchart. That's why the more you use it, the faster you're going to remember how to do it. Okay? Are there any questions?
I have a question about this.
Yeah, go for it.
How you move the 4x minus 5 up there? Is it?
Oh, I just copied it down wrong. Okay. I still got the same answer, but I literally copied it down wrong.
Okay.
All right? Don't kill me for that, okay? All right. So if there's no more questions, we're going to move on with the next objective. Because the next two objectives in this section prepare us for section 5, which is really, or section 4, which is what I really want to get into today. All right? So, objective 2, finding the least common denominator, which we abbreviate as the LCD. Okay? So we're going to do a really easy problem, and we're going to see if we remember how to do this. All right? So here's an example right here. I want you to find the LCD for 1/8 and 3/22. Okay? So how would I go about doing this? Can somebody explain the process? Uh-oh. Have we forgotten already? This isn't looking good. It's not sounding good either. I was hoping somebody would be like, oh, step 1, you do this. Step 2, you do this. All right, let me write out the steps. We'll go over it together. First step, super easy. Second step is easy. However, it's very wordy. So I want to make sure that we understand completely. So I'm going to write out everything. So step 1, better yet, to find an LCD. Or how about a LCD? So to find a... Now I can't even say it. To find the LCD. Better. Sorry, English is very difficult for me. I went to school for math, not for writing. Okay? So to find the LCD, step 1. Completely factor. Step 2, okay, and this is the lengthy one. So the LCD will be the product of unique factors from step 1. All right, now here's the catch, comma. Each raised to a power equal to the greatest number excuse me, of times that the factor appears in any one factorization. All right? So like I said, it's lengthy, but once you see it, it's like, oh, it's actually very easy. So I'll give you a minute to write that down. Like I said, it's a little wordy, But once I show you it, it's like, oh, I see what he was trying to do. All right, so here you go. I just rewrote the problem. So we're gonna find the LCD for 1/8 and 3/22. I am like a robot. I read from left to right, top to bottom, and I follow the directions. So step 1, completely factor. So I'm gonna write the number 8. And I'm going to completely factor this. And the technique I'm going to use is called prime factorization. You remember learning about that? Prime factorization? I mean, the word factor is in factorization. So I need two numbers that multiply to get 8. How about 2 and 4? Now, 2 is prime. I love that. 4 can be broken down into 2 times 2. So over to the right-hand side, I'm just going to write 8 equals 2 times 2 times 2. Okay, now, 22. Two numbers that multiply to get 22 are 2 and 11. And they're both prime numbers. So before I move any further, I need to know, do you know what a prime number is? Who can tell me what a prime number is? Because that's really important.
A number that can't be divided by any other number.
Yeah, that's one. Amanda, that's one way to define it. Another way is that a prime number is a number whose factors are 1 and the number itself. So in other words, the only two numbers that I can multiply to get 11 is 1 and 11. That's it. Okay? Here are a list of some prime numbers. I'll put them up top in red, and I'm not going to write them all because I don't know them all. In fact, I watched a pretty interesting TikTok last night on somebody who was trying to find the patterns on finding all the prime numbers. Because so far, in the existence of humanity, we have never ever found a formula nor a pattern that will give us prime numbers. We can do it for a certain amount, but then after a certain amount, the formula doesn't work anymore. So here are some prime numbers. Like I said, I'll write it right-hand side, top of the screen. Oh, I wrote the wrong word. Prime numbers. 2, 3, 5, 7. Let's see. 8, no, 9, no, 10, no, 11, 13, 15, no, 16, no, 17, 23. And they just keep going. Okay? So the technique that I'm using is I'm breaking down a number. If I say this word, you're not going to understand it yet. A number that is not prime, example 4, is called a composite number. Okay, all right? So what I'm doing is I'm taking all of my composite numbers and I'm breaking them down into the multiplication or factors of prime numbers. Okay? You could think of the prime factorization of a number as its fingerprint. No two numbers have the same exact prime factorization. It doesn't exist. So it's like a fingerprint. So here's what I did. Step 1, completely factor. 8 equals 2 times 2 times 2. 22 equals 2 times 11. All right? Now, here's step 2. Step 2 says the LCD will be the product of unique factors. So the LCD is going to equal, hold on one second. Sorry, Artie had his foot stuck underneath the couch. All right, anyways. No, that's not yours. You don't bite this. Put it up Sorry about that again. So the LCD is going to be the product of unique factors. So when I think of unique, I think of the only one and that's it. So it's going to be the product of unique factors. So I only have two prime numbers here, 2 and 11. And each of these numbers, 2 and 11, must be raised to a power that is equal to the greatest number of times that that factor appears in any one factorization. In other words, the greatest number of 2's that I see in any one factorization is right there. Now, if you look, 8 and 22, they both contain a 2. However, the 8 has 3 of them. So this prime factorization is going to be 2 to the third. And the 11, I only see the 11 one time, and that's right here. So it's going to be 11 to the first. So my LCD is 2 to the third times 11, or 88. Okay? Because 2 to the third is 8, and 8 times 11 is 88. Are there any questions with how I did that? Are there any questions with how I did that? All right, we'll do one more just to make sure we're on the same path. I don't want to use 21. Let's use 12. So we're going to find the LCD for 5 over 12 and... Actually, let's do 5 over 12x. I like that. And 7 over 36x to the third power. Okay? Now, we'll do this together. Step 1. Let's completely factor. 12 is composite, meaning it's not a prime number. It has other factors. So I'm going to multiply two numbers, 3 and 4. I circle 3 because it's a prime number. 4 breaks down into 2 times 2. Are there any questions? Now, if you want, just look up at the screen real quick. Do not write this down. You don't have to write this down. I could have also chose 2 times 6. 2 is prime, 6 breaks down into 2 times 3. Notice the numbers I have circled, regardless of the factors that I initially choose, are the same. You will always break this down into the same exact prime factorization, regardless of the numbers you choose. So don't think, oh, he chose 3 times 4 because he chose that because he had to. No. It's just 2 numbers that multiplied to give me 12. Okay? Next number, 36. Two numbers that multiply to get 36. 4 and 9. 4 breaks down into 2 times 2. They're prime. 9 breaks down into 3 times 3. Okay? Now, I do have an x and I do have an x to the third. We'll worry about them in a second. Okay? So my LCD is going to equal, and you know what I'm going to do? I should have did this down below. I'm going to write out their fingerprints. Okay? So my LCD is going to be the product of all the unique factors, 2 times 3 times x, because x is a factor. And the 2, the 3, and the x, I need to figure out what exponent is that going to be. So if we start with the number 2, notice 12 and 36, they both have 2 2's. So it doesn't matter which one you pick from. But you know, in your LCD, it's going to be 2 squared. Now we look at the number 3. The 3 appears in both the 12 and the 36. However, there's more in 36. In fact, there are 2 of them. So I put an exponent of 2 on the 3. Lastly, the x. Well, if you look at the original problem, the x is in both. It's in both denominators. However, in the first denominator, you only have 1. And in the second denominator, you have 3. So I need the most, which is my highest exponent. So from here, my LCD is going to equal 2 to the second times 3 to the second times x to the third. And last time I checked, that's going to be 4 times 9, which is 36x to the third. And that is my LCD. Does that make sense, everyone? All right. Now the question becomes this. How do we find the LCD for 7x over x plus 2 and 5x squared over x minus 2? Well, the process is the exact same. Nothing changes. Nothing changes. Step 1, you need to completely factor the denominators. That's what you got to do. So if I look at the first denominator, it's x plus 2. Is there a GCF? No. How many terms? 2. Are they squares or cubes? No. So can't be factored. So x plus 2 is going to stay x plus 2. What about the second fraction? Well, the second fraction has a denominator of x minus 2. So that stays the same as well. So step 1 is done. Step 2, we need to write the multiplication of the unique factors raised to the highest exponent. So my LCD is going to be the product of x plus 2 times x minus 2. And notice in step 1, I only wrote x plus 2 down once. And I only wrote x minus 2 down once. So the exponents are 1 and 1 respectively. Now, you don't have to put a 1 there if you don't want to, and that's fine with me. But regardless, there's your LCD. So the LCD between 7x over x plus 2 and 5x squared over x minus 2 is going to be x plus 2 times x minus 2. Does that make sense, everyone? I think, this is just me, finding the LCD of rational expressions, I think is a little, it's just as easy as finding it for numbers. In fact, I think numbers may be a little bit more confusing because you gotta know multiplication and stuff. Here, it's just, you're looking at factors. And remember, the parentheses hold everything together. So that x plus 2 is always going to be x plus 2. Okay? Let's look at another easy one. Let's find the LCD for 3 over x and 6 over x minus 5. All right? Step 1, completely factor. I can't. They're already factored. Step 2, the LCD is going to be the product. The LCD is going to be the product of each of the factors. And since they only repeat once, that's all you get. Any questions? All right, let's have some fun. So now we're going to find the LCD of x minus 5 over x squared plus 5x plus 4 and x plus 8 over x squared minus 16. Okay? Here, we're going to have to do some work. Step 1. We need to completely factor. So, x squared plus 5x plus 4. There's no GCF, a trinomial. A equals 1. So directly underneath, I'm just going to go ahead and write what I need. Oh, wrong number. So how about x plus 1 times x plus 4? Is that x squared plus 5x plus 4 factored? Okay, draw a little line. X squared minus 16. Well, difference of squares. Didn't I say you would see a lot of them? So that's just going to be x plus 4 times x minus 4. So step 1 is now done. I've completely factored everything. Step 2. I need to find the LCD, and that is going to be, and this is key now, it is the product of unique factors. So, I got an x plus 1. Both denominators contain an x plus 4. And I have an x minus 4. Now, I don't have to write x plus 4 twice because it's unique factors. So now I need to go ahead and assign exponents. So the x plus 1 is only repeated once. That's it. So that's going to be a 1. The x plus 4, they both have one x plus 4. So that's going to be a 1. Remember, it's the repeated number of times in one specific factorization. So even though they both have an x plus 4, I only have one in the first factorization and one in the second. So it's only a 1. And the last one is x minus 4. So here is our LCD. So the only thing that we had to do here was factor. Any questions so far? Okay, good. So now let's move over into objective 3. So objective 3 is writing equivalent rational expressions. All right? And I'm going to start off really easy. Okay? Here's what I want to do. So notice here, I gave myself a little bit of space. I wrote 3 over 21, gave myself a little bit of space, and I wanted to equal something over 42. In other words, I want to build 2 equivalent fractions here. Okay, now, you may be asking yourself, what is an equivalent fraction? Well, the word equivalent is equal, and a really easy example is something like this. 1/2 is equal to 5 over 10. They're equivalent fractions. And an easy way to check yourself, there's 2 ways. Number 1, you can cross multiply if you wanted to, because you have a fraction equal to a fraction. Anytime you have a ratio or a fraction equal to another fraction, you can always cross multiply, and they will tell you if they're equal to each other. 10 equals 10, so I know those 2 fractions are equivalent. Another way you can do this is you could take one fraction and try to build the other fraction. Now, in order for these 2 things, 1/2 and 5/10, in order for them to be equivalent, there's only one number that I'm allowed to multiply any number by and still get an equivalent result. And what is that number? Does anybody remember? Because I'm going to multiply 1/2 by something to give me 5 over 10. The question becomes, what am I going to multiply by? And I need to be really clever on how I write this very special number. So let me ask the question one more time. Forget about the fraction for now. What number am I allowed to multiply another number by and still get the same result. In other words, if I wanted to multiply 2 and get an answer of 2, what number do I multiply by? 1. Very good. It's just with fractions, you need to be clever. So I will multiply 1/2 by 5/5. 5/5 is still 1. However, I was really clever on how I wrote that. So 1 times 5 is 5. 2 times 5 is 10. So that's what I did. I'm going to do the same exact thing on the left-hand side. Okay? Now, you may be asking yourself, okay, well, how do we do that? Okay? Excuse me. If we think about the 3/21, all right, if we think about this, 21 is going to equal, you know what? I think that's even confusing us. We'll keep it simple for now. What number am I going to multiply 3/21 by to get 42 as a denominator? In other words, 21 times what equals 42? 2. Good. So if the bottom is 2, then the numerator also has to be 2, because I'm only allowed to multiply by 1. So the number that we were looking for up top is a 6. Now, with numbers, I think it's kind of easy. But let's see what we can do here in terms of rational expressions. All right. So here's a rational expression. 3x over 5y equals, now, I want to build an equivalent fraction so that my denominator is 35x times y squared. Okay? How would I do that? Well, take it one step at a time. You know, we're going to multiply this fraction. 5 times what gets you 35?
7.
Good. So I put a 7 in the top, 7 in the bottom. Now, I need an x downstairs also.
Seven xy.
Say that again.
Xy. 7xy.
Okay, but here's the problem. If I do the bottom by 7xy, I have to do the top by 7xy also. Is that correct? All right. So, what's my equivalent fraction? 21 x squared y. Are there any questions with how we built that? All right. So let's do what I think is an easier problem. Here's one more. We're going to do 9x over 4x plus 7 equals, oh, sorry, let me give myself some space. $8x plus 14. Now, whenever we start digging into rational expressions, it's actually a little bit easier. It's actually a little bit easier. So let me show you why. What I'm going to do here is I'm going to factor that. And look what I get. I could definitely factor out a 2 to give me 4x plus 7. And if you look here and here, notice they're the same. So the only thing that I really need to multiply the top and bottom by is a 2. So what am I going to multiply this by? 2 over 2. Because notice 4x plus 7 times 2 is 2 times 4x plus 7. Excuse me. And in the numerator, you get 18x. Are there any questions? All right. So here comes the fun part now. All right. We're going to go into section 4. So let me go ahead and just do this. Type it in. 14.4 is going to be adding and subtracting rational expressions. Oh, come on. With unlike denominators. Okay. Now, adding or subtracting with unlike denominators is the exact same thing as adding and subtracting fractions with unlike denominators. You're going to have to find an LCD, okay? And it's really easy to do, provided you just follow the steps. So, to add or subtract rational expressions with unlike denominators, and that's the key. We need to find the LCD. Okay? So, let's look at an easy example. 2x over 5 minus 6x over 15. That's a horrible looking 15. All right, now, there are plenty of ways to do this. All right? Some of us know shortcuts, and that's fine. All right? I don't know what you know. So I'm going to just show you the easiest way to do this. At least it's easy for me. Okay? And it's a little bit lengthy, but I hope it makes sense. Okay? So, step 1, let's find this LCD. All right? So 5 is going to equal 5. It's prime. 15 equals 3 times 5. So my LCD is going to be the product of unique factors raised to the highest exponent. So my LCD here is going to be 5. All right? Maybe I should have wrote out find LCD. Okay. Step 2.
LCD is 5 or 15?
Oh, 15. I didn't write the 1 there. Step 2. We're going to build equivalent fractions. Now, here's how we do this. So, if you want, just watch for a second, okay? I need to take the first fraction, which is 2x over 5. I know I want a denominator of 15, because that's my LCD. The question becomes, what do I multiply 5 by to give me 15? Well, that's going to be 3. And since I'm only allowed to multiply by 1, I write 3 over 3. So my first fraction turns out to be 6x over 15. Does that make sense, everyone? Now, I need to do this with the second fraction as well. So the second fraction is 6x over 15. I want a denominator of 15, but I already have my denominator of 15. So I just multiply by 1 over 1. Nothing changes there. Okay? Are there any questions so far? So step 1 is find the LCD. Step 2 is to build equivalent fractions. And then my last step, perform the operation. So I have 6x minus 15. That's the first equivalent fraction, minus 6x over 15, which is my second equivalent fraction. I write one denominator and all the numerators up top. 6x minus 6x is 0 over 15. So this equals 0. Okay? Does that make sense, everyone? Yes or no? All right, let's do another one. We'll do one more, okay? Because these are kind of straightforward. If I'm moving too fast, you got to let me know. All right? So here's our second example. Add 7 over 8 plus a, or 8a, and 5 over 12a squared. Okay, so step 1. Let's find the LCD. All right, so I zoomed in. So here we go. Let's take our time with this. We know we got A's. We'll worry about the A's when we build the LCD. First number is an 8. So we'll break this down. 8 equals 2. Actually, I'm going to write it off to the right here. 8 equals 2 times 2 times 2. 12. It's 4 times 3 and 2 times 2. So 12 equals 2 times 2 times 3. Now, my LCD is going to equal the product of unique factors, 2 times 3 times the letter A, and I need to find the most in each factorization. So, the number 2, the most 2's I see are going to be 2 times 2 times 2. So this is going to be 2 to the third. The most number of 3's is in the factorization of 12, so that's going to be 3 squared. And then the letter A, in the first fraction there's only 1, in the second there's 2, so this is going to be a 2. So my LCD is going to be, what is that, 8 times 9, 72a squared. Wait a second. Yeah, no. I made the mistake right here.
Okay.
I was going to say, yeah, that seems like a lot. So, sorry, it's 8 times 3, 24a squared. Who was going to correct me there?
I was.
Thank you, Samantha. I just wanted to say thank you. Amanda. Oh, okay. Next, we know what our LCD is. Step 1 is done. Step 2, build equivalent fractions. So here's what we know. I got to zoom out here just a little bit so I see my fractions. Here we go. So my first fraction is 7 over 8a. I know I'm going to multiply this by something, and I want my denominator to be 24a squared. So what am I going to multiply by? Well, 8 times 3 is 24, and a times a is a squared. So I'm going to multiply the denominator by 3a, which means I need to multiply the numerator by 3a as well. So my first equivalent fraction, 21a over 24a squared. Does that make sense, everyone? So maybe you should do this. Just put like a little circle around that because you know you're going to need that. The second equivalent fraction. Well, I start off with 5 over 12a to the second. I know I'm going to multiply by something, and I need 24a to the second as my equivalent fraction. Start with the numbers. What number times 12 gives you 24? 2.
True.
Now, you have an a squared in the denominator, and you need an a squared. So I don't have to mess with the a's at all for this one. So this is just going to be 2 over 2. So my second equivalent fraction is 10 over 24a squared. So now step 3. All we need to do is combine. 21a over 24a to the second plus 10 over 24a to the second is going to equal, well, we know our denominators are now the same. So I write the denominator once, and I write the numerator out. And I always need to ask myself, and now I'm going to write this in step 3 in red. Always simplify if possible. So I look at the numerator. It's 21a plus 10. I cannot combine those. There's nothing I can factor. So it's already simplified. Does that make sense, everyone? Okay? Now, let's get a little bit more involved. Okay? Example. 6x over x squared minus 4 minus 3 times x plus 2. Okay. Now, with this one, we're going to follow the same method. Step 1. Let's find that LCD. X squared minus 4 equals x plus 2, x minus 2. It's a difference of squares. X plus 2 is already factored. So my LCD is going to be the product of the unique terms. So in any one factorization, I see x plus 2 at a maximum one time. And then the x minus 2, I see that one time. So I know my LCD is going to be x plus 2 times x minus 2. Step 2. Let's build our equivalent fractions. All right, so here we go. My first fraction is 6x over x plus 2, x minus 2. Now, I need to multiply this by something so that my denominator is x plus 2, x minus 2. Luckily for us, we already have that. So I don't have to do anything. Therefore, it just stays the same. Does that make sense, everyone? Okay? For the second fraction, 3 over x plus 2. Now, I need to multiply this by something so that I have x plus 2 and x minus 2 in my denominator. What am I going to multiply by? Any idea?
X minus 2.
Good. So, in the top, this is going to be x minus 2. And in the bottom, it's going to be x minus 2. So, my numerator, I'm just going to write 3 times x minus 2. Okay? Are there any questions so far? All right. Step 3, which is our last step. We're going to combine and simplify if needed. So all I'm going to do is just rewrite with equivalent fractions. 6x over x plus 2 times x minus 2 minus 3 times the quantity x minus 2 over x plus 2x minus 2. Now that I have common denominators, I'm just going to write it once. And I need to be careful because I have 6x minus the quantity of 3 times the quantity x minus 2. So remember, I put that second thing in parentheses. Now, it's just a matter of figuring out what the numerator simplifies down into. That's it. So, 6x minus 3x, what is that, plus 6? Do you guys agree with that? Okay. All over x plus 2 times x minus 2. That's going to give me 3x plus 6 all over x plus 2, x minus 2. I need to make sure that numerator is completely factored. I can factor a 3 out. So that leaves me with 3 times the quantity x plus 2. And that's all going to be over x plus 2 times x minus 2. And then hopefully from here you can see that the x plus 2's reduce. To leave us with 3 over x minus 2. So, let's think about this. These problems take time. They do. There is no trick. You already knew how to do this problem walking into this class. It was being able to really get all of your information, as my dad would say, to get all of your ducks in a row. Get them all lined up. We know how to add and subtract fractions. We know how to find LCDs. We know what rational expressions are, and we know how to factor. How do we bring all that together? That's what we did here in this problem. Okay? Now, the process that I gave you, so I'm going to zoom out here a little bit, so it's just so we could try to see everything. So this process I gave you is, I will admit it, it's lengthy. It'll take some time. But what's nice about this, there are steps. And every single time you do this, you can use this method. But there's another way to do these problems, which is much faster. I'm going to do it off to the right. So if you want, because we already have the answer, just watch, okay? All I'm doing is rewriting the problem. All right. Now, without going through step 1, finding the LCD, building equivalent, without doing all that stuff, I'm going to look at my denominators and just factor. Okay, that's all I did here is I just factored. Now, if I take, oh, come on. Now, if I just take 1 second and look at my denominators, look what they have in common. They both have the x plus 2. Would you all agree? The first fraction has an x minus 2. And if I wanted a common denominator, I would have to multiply the second fraction by x minus 2. Now, if you look, they look the same. So what I'm going to do here is I'm going to rewrite everything how it looks, except now that I can see x plus 2 times x minus 2, x plus 2 times x minus 2, I'm just going to write the denominator once. Do you see how much quicker that is? Okay? So, with basically just taking a step back and understanding how to find LCDs real quick, I got us all the way down to that step real quick. It doesn't matter what method you choose. Some of us like to really just piece things together. Others, you could do this real fast. All right? It doesn't matter to me. What matters to me, are you getting the correct answer? So from here, you would just do all your math. And you would still come up with 3 over x minus 2. All right? Are there any questions? All right, let's do a couple more examples then. Oh, sorry. Am I moving too fast? You want to write this down maybe? For those of you who are not writing anything down, here's your daily Artie video. There he is. He's just sleeping. Sleeping in the sun. He's getting very big now. I think I say that every class though. I'm just a proud dad. Dog dad, I guess I would be considered. Puppy dad. Okay, are we good? All right, so another example. Let's do 3 over 5y plus 2 over y plus 1. And I'm going to do the second method. That quick method I showed you. Because I think maybe we could be okay with that. So here's what I know. I need to add these together. They do not have the same denominator. All right. My LCD is going to be the product of unique factors. So that's what it is. So what I'm going to do is I'm going to multiply the first fraction and the second fraction by whatever I'm missing in my denominator. In other words, in the first denominator, I got the 5 times y. What I need is a y plus 1. And in the second denominator, I already have the y plus 1. I need the 5y. So, before I do any math, I always write down the denominator once. Actually, let me write it the other way because we're used to seeing 5y times the quantity of something second. And now I'm just going to write the entire numerator. And just watch how I write this. 3 times the quantity of y plus 1 plus 2 times the quantity of 5y. From here, it's just a matter of simplifying the numerator. That's it. I don't have to worry about distributing a minus sign because I don't have a minus sign. So that's good. So I get 3y plus 3 plus 10y in my numerator. My denominator, I leave it factored. Because remember, eventually you're going to simplify if possible. So it's always good to leave your denominator completely factored. So upstairs in my numerator, 3 plus 10 is going to be 13y plus 3 all over 5y times the quantity y plus 1. I ask myself, can I factor anything? And the answer to that is no. So that's already simplified. How are we looking? Pretty good? Like I said, this isn't difficult. It's bringing everything that you know together. Am I moving too fast? Are we okay? All right. Next example. 6 over x minus 5 minus 7 over 5 minus x. Anybody notice anything here? Yeah, what do you notice?
first one is x minus 5, the other one is 5 minus x.
So they're like the same terms, it's just they're the exact opposite signs, correct? In fact, if I wanted to, I can, and I'm a huge fan of this. You should know this by now. I like the variable first, number second. I see that these denominators are the exact same, just opposite signs. How do I change signs? How do I change signs real quick? We went over a problem like that. Anyone?
Is it multiplied by -1?
Not multiply. What's the opposite of multiply? Starts with the letter F, rhymes with actor. We're not going to multiply by -1. We are going to factor a -1. See, that was the starts with the letter F, rhymes with actor, factor. All right, my jokes are real chintzy. They're real like dumb. Like everyone's a lot more intelligent than my jokes require. That's why sometimes people don't get them. So here's what I'm going to do. I'm going to rewrite the first fraction. I'm going to put a minus sign. I'm going to factor a -1 out of the denominator of the second fraction. So now my denominators are the same. And another thing happens. Look what you have here and there. You have two negatives back to back. We know when we have two negatives back to back, it's going to change to a positive. So my denominators are now the same. It's going to be 6 plus 7 in the numerator. And last time I checked, 6 plus 7 is 13. How are we looking so far, everybody? All right, let's get to the fun stuff. Because we didn't even do the fun problems yet.
Mr. Flo,
Yeah.
I'm confused.
Where are you confused at?
Okay, so you have 6 over x minus 5 minus 7 negative x plus 5.
I don't have negative x plus 5.
And then you add the two negatives to get a positive.
Yes.
But where do you get the -5 from?
What do you mean a -5?
I don't know.
Here, look.
I think I'm confusing myself.
Look right here. So I want to factor a negative out. Okay?
Yeah.
When I factor out a negative, all I do is change the signs of the terms that I originally had. So since the x was negative, it's now positive. Since the 5 was positive, it is now negative.
Oh, okay.
Does that make sense?
Yeah.
Okay. You scared me there for a second, Samantha. My heart started to beat a little quicker. I thought maybe I did something wrong. Because you corrected me earlier today, didn't you?
I did.
That fear sets in. All right. Let's do a fun one now, okay? All right. Ooh, here we go. 5 over 2x squared plus 3x minus 3x over 4x plus 6. Okay, here's the fun one. I want you to take a second and I want you to think about all the problems we've done so far. Look at the denominators. Here, look at this one, this one. Let's see here. This is step 3. Hold on one sec. This one. I mean, even this one and this one. They were basically already factored. This is the first problem. I'm going to scroll all the way back down. Where we are literally going to have to factor both denominators. From here on out, every single problem you do, you're going to have to end up factoring denominators. Sometimes it's easy. Sometimes you're going to have to do that dreaded AC method. And that's when you're going to want to beat me up. And I'm going to ask you very nicely that if you see me in public, not to do that. Especially if I'm with Molly. All right? Because she'll cry. So, here's what we do. Step 1. Oh. Completely factor the denominators. I'm so excited I'm misspelling words. Step 2. Find that LCD. And then step 3. Write equivalent fractions, which is basically the same exact steps that we've seen before. It's just we're just going to speed it up a little bit. Okay? So I'm just going to rewrite the problem real quick. I'm going to write it nice and neat. Now I'm going to factor both denominators. So the first one, GCF, looks like an X. All right, and that's completely factored there. Second fraction, I can factor 2. Oh, that's lovely. So if you notice, both fractions contain a 2x plus 3. The first fraction has an x. The second fraction has a 2. So I know my LCD is going to be 2 times x times 2x plus 3. Does that make sense, everyone? All right, now, watch what I do. Please, I'll give you a minute to write it down. Just watch. I'm just going to write 5 over x times 2x plus 3 minus 3x over 2 times 2x plus 3. I know I need to build equivalent fractions. So now all I really do is I look and I ask myself, okay, what else do I need? Here's my LCD. For the first fraction, the 5 over x times 2x plus 3, I already got the x. I already have the 2x plus 3. It needs a 2 over 2. For the second fraction, I already have a 2. I already have the 2x plus 3. I need the x, so it's going to be x over x. Does everybody see how I did that? Okay? Go ahead and write that down. I'll wait to do the next move. Okay, how are we looking? Pretty good? All right, here's my next move. I already know that my LCD for both fractions now is the same. So what I'm going to do is I'm going to write what my LCD is. And I'm going to write the entire numerator the exact way it looks right now. I'm not going to simplify anything because I want you to see this. 2 times 5 minus 3x times x. Now, don't forget, always put that second numerator in parentheses when you got a minus sign. It just helps. From here, I'm going to rewrite my numerator. Rewrite the denominator and simplify the numerator. 2 times 5 is 10. Negative 3x times x is going to be minus 3x squared. Okay? And then from here, I'm just going to rewrite it in descending order because I'm a huge fan of that. I asked myself, can a numerator be factored? The answer is no. So I know I'm done. Does that make sense, everyone? How are we looking so far? Pretty good? All right, let's do one more for today. We'll do one more problem for today. All right. So we got, excuse me, we have 2x over x squared plus 2x plus 1 plus x over x squared minus 1. All right. Somebody help me. What's my first move?
Factor.
Completely factor denominators. Love it. So I'm going to do it directly underneath. There's my first denominator factored. My second is difference of squares. So it's going to be x plus 1 times x minus 1. Now, what's my next move? Sorry if you can hear Artie in the background. He's dreaming. He's barking right now. So what would be my next move here?
Find the LCD.
Perfect. I'm going to write it off to the right. So the LCD is going to be the product. Now listen, it's the product of unique factors. So x plus 1, x minus 1. Those are my unique factors. I got to find exponents now. In the first fraction, I had 2x plus 1s. And in the second, I only have 1. So I know my LCD is going to contain 2 of them because that's the most times I see it. Now, the x minus 1, I only see that once, so I know that's just going to be a 1 up there. Does that make sense, everyone? So sometimes it really helps if you just write it all out. I realize it can be overwhelming because it's a lot of writing, but hopefully in the next step you see why. So, my next move here, this is what I do. I want to build my equivalent fractions. So what I'm going to do is I'm going to write 2x times x plus 1 times x plus 1 in the denominator. Second fraction, I'm going to rewrite it. I know I'm going to multiply to make equivalent fractions. Actually, give me one. Yeah, that's fine. So, if I look at the first fraction, I have 2x plus 1, so I put check marks underneath them, where my LCD is. I need an x minus 1. So I'm going to write x minus 1 over x minus 1. Does that make sense, everybody? Now, for the second fraction, I already have an x plus 1. I already have an x minus 1. I need another x plus 1. Does that make sense, everyone? All right. Now, I know my denominators are the same now. So I rewrite the entire numerator and only write the denominator once. 2x times x minus 1 plus x times x plus 1. I put the second thing in parentheses all over x minus 1 times x plus 1 times x plus 1. It really doesn't matter the order. All right. Now I simplify the numerator. just write out that denominator, which is the boring part. So now, numerator, I need to distribute the 2x. 2x times x, 2x squared. 2x times negative 1, minus 2x. I also need to distribute the x. X times x is positive x squared, and x times 1 is plus x. Now I'll go ahead and group like terms. 2x squared plus x squared is 3x squared. Negative 2x plus x is going to be minus x. And this is all over x minus 1, x plus 1, x plus 1. I simplify the numerator if necessary. I'm going to factor. I got a GCF of x. So that's going to be x times the quantity 3x minus 1 all over x minus 1, x plus 1, and x plus 1. I take one more second and I ask myself, can I simplify anything? I'm looking at Jada. She's shaking her head no, and I agree 100%. All right. I'm done today. I think we did a lot. I'm done with section 4, which is adding or subtracting rational expressions with unlike denominators. Hopefully now you can appreciate why we show you how to multiply and divide first, because it's a lot easier than adding and subtracting. Okay? Remember, you have homework. It is due the last day of the semester, which is right around the corner if you really think about it. It's May 10th, and today is April 22nd, so it's right around the corner. All right? If you have any questions, please stick around.